Have you been wondering what is a service in Kubernetes architecture? Have you been thinking, how should I write a code to create a service? If yes, in this video, I'm going to make it easy for you. Let's get started. What are you going to learn over the next few minutes by watching this video? I'm going to talk about what exactly is service in Kubernetes architecture. How can you write a code for creation of a service in the most simplest manner? And what are the various use cases of different services that we create in Kubernetes architecture? I always believe that the best way to learn any technology is to do hands-on. And I always prefer that if possible, you follow along with me. So what is it that is required for you to follow along? You need a Kubernetes architecture, a cluster which is up and running. I'm going to use Minikube, which is set up on my local laptop. You can make use of any Kubernetes cluster, whether it is on AWS, Google Cloud, or anywhere else. I'm going to use Oracle VirtualBox, and then kubectl must be installed on your system. So having said that, let's get started. Before we dive into service, let's discuss about pod. What is pod? Pod is one of the smallest deployable units when it comes to Kubernetes architecture. What do I mean when I say smallest deployable unit? Every pod mainly holds one container. It could be multi-container pod as well. So think of pod like a simple box which has a container. When we talk about containers, these are run based on some specific images. So in take it as a general example, let's say Nginx. You have created a container using Nginx base image. And this is what we encapsulate in a pod and give it a name. So in Kubernetes architecture, the base component on which your application runs is your pod. Now, everything that we are going to talk about service revolves around this pod. Let's see what service is. It is a way to expose your application. The whole purpose of us creating a pod, deploying a pod on Kubernetes is for the different set of users to be able to access our applications. So service gives you a way to access those different pods which have been set up in Kubernetes architecture. Let us say you have a Kubernetes architecture cluster created, on top of which you are going to run your applications in some specific namespaces. And you create a pod for your application. Let's say the load that is coming in for your application, one pod is not sufficient enough. So you deploy one more pod. Then after a while, you deploy another pod. But for external users to be able to access all these pods, every time a pod is created, it gets destroyed, it gets created again. The IPs keep on changing. You cannot give the end clients the IPs of your pods. So you need a way for all these different IPs of your pods, which represents your application, to be behind a specific virtual IP, which is what service is. It is a way for you to expose your different applications which you have set up in your Kubernetes architecture. And your end clients are going to use or initiate the application traffic towards this service. So they are just going to open up the browser and then type app myapp.com. And this is going to resolve to an IP address which is being represented by your service, IP address, and a port combination. And from there, it is going to be routed to various pods. Now, let us see the various service types. When we create a service, by default, the service which gets created in Kubernetes architecture is a cluster IP. We'll see more in details on how this cluster IP gets created and how does it look like. Then the second service type is NodePort. It is a way for you to expose your applications based on the node ports of your worker nodes. So your application traffic hits on some specific network interface on your worker nodes, and that traffic is being forwarded to your actual pods which are running in your Kubernetes architecture. And the third type of service creation is external. So within which we host a specific load balancer, and all your incoming requests for your application comes through your load balancer, and from the load balancer it gets redirected to the various pods. Now with this, let's try to understand few basic terminologies on which can help us write the code for services. Let us say we have deployed an application pod on our cluster. Now we know that every application that we host, run it on some specific standard ports. So let's say, considering your application is HTTP based and it is running on port 80. So in this case, you have launched multiple pods in your cluster. Now this port 80, which is running on your pod, is called as target port. These terminologies you have to know in order for you to be able to write the code for uh, creation of any object in Kubernetes. So I'm at present focusing mainly on service. So your app pod runs on specific port 80. So this is what we call as target port. Now the two pods are already running in my Kubernetes cluster. I'm going to create a service so that those services can help those that specific service which is running on some specific port, IP and port, is going to route my traffic towards the application pods. So the service that going to define on my the ports that I'm going to define on my service, those will be referred to as ports. And from these services, the traffic is going to be routed to the pods. Now, in this specific case, service is acting like a front end. So all your application traffic will be hitting your service, and from there, it is going to be routed to your application pods. So in this case, the application pods are uh, endpoints for your service. Now, coming to the concept of how a service which you create will come to know that the traffic has to be routed to which pod. Every time a pod runs, it comes up with a different IP address. Let's say the pod gets destroyed, again the IP address will change. So that is something not which is not static. So we need a way for us, or for the service, to be able to identify, okay, whenever any requests are coming in, those have to be routed to these specific pods. So that is what we are going to make use of labels. Labels are like tags. So let's say these application pods which I'm running in my Kubernetes cluster, I give it a label as app is equal to web. So this label is what going to be used in my services. So all the pods which are running in your Kubernetes cluster will be assigned a specific label. Label is a key value pair. And then your service is going to make use of a selector. So selector is a component which decides, okay, which specific set of pods will be associated with this service. Now, based on any object which needs an access to the app pods, where app is equal to web, they can access this specific service and they will be routed to any of these application pods. Now, with this, the basic terminologies that we have discussed, let's now jump into writing the code. This is my workspace. In here, I have created two files, the pod.yaml and service.yaml, where I'm going to define my code for creation of service and the pod. So let's see. First, if I look at my Kubernetes cluster, I have a single node cluster, which I have set up using Minikube, which is acting both as a control plane as well as the worker node, the master and the worker node, which is running on version 1.20. Now, let's see. First, I have a target to create a service. So the first thing that should come into mind is, or the question that you should ask yourself is, what is it that I have to create? Okay, let's say I want to create a service. So I will just type in service. Now, every object that you create in Kubernetes is, when you are going to define a YAML code file, it follows different kinds. So service is a kind, pod is a kind. I'm just giving an example. So the way that you are going to define this in your YAML definition file is kind colon service. Now, this service, definitely you are going to give it a name. So that name is what we define it as a metadata. So I'm going to type in metadata, and let's say within this metadata, I'm going to give it a name as, let us say I'm going to give it a name as mylb1. Now, this service that you are going to create, it is going to have some specific general properties. Like we have seen, when we created a service, we have to define a selector so that it selects some specific pods which will be considered as the endpoints of your service. So in this case, the details or the specifications which I mentioned have to be under spec section. So in here, I'm going to define my selector. Now, what is my selector? My selector is the labels that I'm going to give in my pod. So there can be multiple labels. So I'm just going to give a label as app. Let's say app has a value of web. Now, when I'm going to create my service, I have to define it on some specific ports. We have seen what are the ports of your service and then the ports on which your application is running. So that is what I'm going to define as a within specification as my ports. Now port is again a list. So I'm going to define this as, let's say, we have seen target port. Target port is the port on which your application is listening. So my application, let's say, is listening on 80, and the port on which I'm going to create my service is port 8080. So this way, now my service definition is created. I have written almost 9 lines of codes. Now in Kubernetes, whenever you are planning to write a code for creation of any object, each object follows a specific API version based on how it is being released and what are the different features it supports. So you also have to define that in your YAML file. So that is what I'm going to define at the top, saying API version v1. Now with this, I have now written my code for service. Let me jump on to my command line and first check, do I have any existing services created? So I can give kubectl get service. So we see that at present service named as Kubernetes is created and the type is ClusterIP. Now, if I want to get more details about this service, I can make use of kubectl describe Kubernetes. So this will give you more details about the service, the name of the service, in which namespace is it created, what are the labels associated with it, if there is any selector which is defined, what is the type of the service, what is the IP address, on which port is it listening, what is the target port, what are the different endpoints. So all these details will be created. So at present, apart from this, I don't have any service for my application. So now I have defined my code in service.yaml file. Let's try to create a new service based on this. So what I'll do is I'll just use kubectl apply and then use my file where I have defined the service. But you see, we got an error. Let us see one by one what is the error. So it says error validating this file, validating the data API version not set. So in here, if you see API version, it should be API, V should be capital. So there are some specific standard names of the objects which you have to follow in the same format. So in here, even though we have defined API version as V1, it should be actually V should be capital. So the best way for you to be able to write the code for creation of a service is make mistakes, try to take it step by step. Let's fix this. So API version we have defined now as a V1. Let's try to create it again. Now this time if we see, it says service in version V1 can cannot be handled as a service. No kind service is registered in V1. So by chance, this kind, the object type which we are creating, the S should be capital. So after we change this, let's try to run this again. Now, this time we see it says unknown field target port. So in your YAML file, this keyword is actually with P as capital, target port. So let's change this and save it. Let's run it again. Now in here it says invalid value my lb1. So it must consist of lowercase letters. So the name that I have given, let me just change it to, let's say, my lb1. Let's create it again. Now this time you see you have finally succeeded. And it is the simplest way, we got to learn few things on how our code should be written. And one of the most important things when you are writing the code is your indentation. That should match, otherwise it will give a syntax error. So now my service is created. At this point of time, if I see kubectl get service, you will see a new service created with the type as ClusterIP. So in my code, I have not defined the type. When you have not defined the type, the default type is ClusterIP, and it will assign an IP address which will be accessible only from within the cluster. This cluster IP will not be exposed to external users. So if from my host machine, if I try to ping or reach to this IP address, it will not work. So now, if I want to see more details about this specific service, what I'll do is I'll just again use kubectl describe my lb1. In here you can see name, it is mylb names, it is everything. If you have not defined your namespace, will get created in your default namespace. And we have defined the selector is app is equal to web, and at present we are listening on port 8080. The target port is port 80. But in here, if we see the endpoints, there are no endpoints currently associated with this service, which means any traffic which is being directed towards this IP on port 8080 will not be sent or to any of the ports. So at present, if I look in my cluster, if I look at pods, there are no resources, no pods currently created. So let me quickly write a code for creation of a pod as well. So in here, these four sections will always be common. So in order to save time, what I'll do is I'll just copy this and paste it here. So in my pod definition file, what I have done is I've defined the API version, the kind. Now this time I'm going to create a pod. So kind will change from service to pod. Now, when it comes to pod for your, the definition for your pod, in here the metadata will be having your name of the pod. So let's say I'm going to give it a name as my pod 1. Now, we have seen that it is very important if you want to associate your pods with a service, the service will be acting based on specific labels. So I also have to define my labels here. So in the metadata, I'm going to give labels, and with label, I'm going to give it as app web. And this label is exactly same as what we have defined in the selector section of your service. So now with this, coming to the spec section. We know that the pod which is going to get created will have a basic component which is our containers. So in the specification, it will have containers. Now a pod can have multiple containers. So I can give it as a define as a list, and each container again will have a specific name. So I'm going to give a name as, let's say, my container 1, and this container is going to be created based on specific image. So it is important that I follow the indentation. So I would have to give the details of the container in the same line as the name. So I'm going to give, let's say I'm going to use an image of Nginx. So I'll just choose this image. With this, my definition for creation of the pod is completed. Now let me go ahead and quickly apply this. Now with this, again we are getting an error saying when creating the pod in version v1 cannot be handled as a pod. So ideally the kind should be defined as pod, p in capital letters. So after I change this, let me try to apply it again. With this, now we will see that the pod got created. And if I again check kubectl get pod, I'll see that my pod is running. Now, similar to the case of service, if I want to see more details about this pod, I can use my describe command, my pod 1. Now, with this, if I scroll up, I will observe that the pod got created with the name that I have given. It got created in the default namespace, and the name is node name is minikube, and it has got the labels of app equal to web, and it got an IP address 172.17.0.3, and the containers, it has a name of my c1. This my c1 is exactly same as the name that I have defined it here, and this container was created using an image of Nginx. Now, coming back to our use of service, let's see. If I check my service again, my LB1. Now, this time, if I do a describe kubectl describe service my LB1, I will observe that this MyLB got associated with an endpoint 172.17.0.3, and this IP is the exact same IP of my container which we just saw. Let me go back. This is an IP address. This is the IP address of my container. So let me just quickly, let's say, delete this, delete pod my pod 1. Now, after deleting this, if I do a describe again, you will see there are no endpoints currently associated with your service. Now, this service that we have created is of type cluster IP. This is one of the types of your service. And let me quickly create the pod again. And in here, if we check the service once again, we will see the endpoint getting associated again back with my service. But this service, which is having an IP address of this and listening on this port, if we try to access it from the outside, I will not be able to. I do not have reachability to this IP on this port. But if I check it from within my cluster, let's see if I go back to my node. This is my node. From here, if I do a curl and curl for my IP address of the service 10.104.83.141 and listening on port 8080. We are getting an error. Sorry, my bad. And we are getting the Nginx page. So with this, we can see that from within the cluster, this is an IP address of my node 192.168.99.100. From within the cluster, when I'm trying to access my service, it is reachable and accessible. So using that IP address on port 8080, I will be connected to my pod. But let's see if in this specific case, let me go back to my workspace. In this specific case, let's say I'm going to create one more pod, but this time I'm not going to define the labels. See, kubectl apply -f pod. And then if I check kubectl get pods, my container is getting created. Now container is running. My pod is running. At this point of time, if I look at my service, this service is still having only one endpoint associated with it. The reason why the second pod did not get associated with this service is because we have not defined our labels. Now let me go back and add the labels here. Let's say this time I'm going to give it a name as 3 and define the labels. Say app web. And let me create a new pod again. And now if I look at the list of pods, I have still getting created. Okay, I have 3 pods running. And in here, now if I describe my service, my LB1, I will see that earlier I had only one endpoint associated with it. But now I have 2 endpoints. And this 0.5, if I describe my pod, kubectl describe pod, my pod 3, I will see that The 0.5 is the IP address which is assigned to this port. So this way, now we have seen that every time we are going to create a pod and we define the selector in our service, these pods are automatically getting registered to your service. You don't have to do anything. You have already defined this selection criteria here. In the service, you have defined the selector as app equal to web. So whichever pods have this label added, those will get automatically associated with your service mylb1. Now this kind of service is your cluster IP service. Now what if I want to expose, I want to access my applications? So with cluster IP address, I will only be able to access my um, application from within the cluster. We have different microservices running on the cluster, and then maybe the app server wants to talk to the database wants to talk to any other third party component services. So all those are will be having their own services defined. Now in this specific case, I want to expose my application to the outside world. So one of the options that I have is NodePort. Now, in this case, I can define my type. So when I'm creating my service in here, by default, if you don't mention any type, the way that it is going to be exposed or created is your cluster IP. That is the default one. Now, in order for me to create the service of NodePort type, I would have to explicitly define it here. So within your definition of the service file, you would have to define the type. So the type comes in the specification. You would have to select the type, and I'm going to define or create the service of node port type. So I'm going to mention the type as node port. And you have to keep in mind is when you are defining the type, in here N is capital and P is capital. And then when you are defining the node port, you can also mention on which port the service is going to be exposed on your node network interface. So that is what I'm going to define in the port section. So I'm going to type as node, and in here port P is capital, node port, and this you can choose in 30,000 range. Let's say I'm going to choose as 30,007, and let me just change the name of the service as mylb2. I'll let the selector be the same. Let me create the service. svc.yaml. Now this time a new service got created, mylb2. If I give kubectl get service, I will see a new service got created with the type of node port. It got an IP assigned, and in here you would see this port is again associated with your node port. So node port is the actual port on which your application traffic will be hitting on your worker node, or whichever node that you have exposed it on. So in my case, it is the minikube VM. So if I go to my minikube, in here, if I look at my interface, this is my interface address. So if on this interface, and I'm going to access it on 30,007 port from my host machine, I will be able to access the pod application which is running in my Kubernetes cluster. So let us give this a try. And we can see that this web page that we are getting is from my application pod. So this way I can expose my applications and create a service of type NodePort such that my external users will be able to access my application. So for now, I will wind up here. The third type for load balancer, we'll see it in the next video. I hope you found this informative, and thank you for watching.